Solutions to systems of equations. In this video, you'll learn how to tell how many solutions a system has by graphing the equations or by analyzing the parts of the equations. So far, we have seen that systems of equations have one pair of points that satisfy both equations. A system of equations can also have no solutions or infinitely many solutions. So let's look at each type. If a system has one solution, this means that a system of equations has only one pair of values that makes both equations true. The equations in the system will have different slopes, and solving the systems will result in exactly one ordered pair. The graph of the systems will look like two lines that intersect at one point that represents the solution. Now let's look at what happens when there are no solutions. This means that a system of equations has no pair of values that will satisfy both equations. The equations will have the same slope but different y-intercepts, meaning that they're parallel. When we solve the system, this will result in a false equation, like 3 equals 5 or 2 equals 7, or any equation that's incorrect. The graph will show two parallel lines that never intersect, which makes sense because they don't have a solutions, which is usually where the intersection happens. Now let's look at infinitely many solutions. This is when a system of equations has an infinite amount of solutions that will satisfy both equations. The equations in the system are equivalent, so they're multiples of each other. Solving the system for this equation will result in a true equation such as 5 equals 5 or 2 equals 2. The graph will show two lines on top of each other since they have the same slope and y-intercept. Let's determine how many solutions this system has. So we have y equals 2x plus 4 and 4x minus 2y equals negative 8. The first equation is already in slope-intercept form, but let's make the second equation in slope-intercept form also so we can compare them. So we'll take our second equation and solve for y. So we'll subtract 4x from each side, giving us negative 2y is equal to negative 4x minus 8. And then we'll divide both sides by negative 2, giving us y is equal to 2x plus 4. So if we look at this equation and the first equation that we had, they're the exact same equations. The slope matches and the y-intercept matches. So that tells us that this system will have infinite solutions. Let's see how many solutions this system has. Our first equation, y equals negative 3x plus 1, is in slope-intercept form. So let's take our second equation and also put it in slope-intercept form. To solve for y in this one, we just need to subtract 3x from each side. So we have y is equal to negative 3x plus 4. So if we compare this to our first equation, we see that our slopes match, but our y-intercepts are different. So this says that the lines will be parallel. So this has no solutions. Now let's create two systems that have no solutions. So when a system has no solutions, that means that they have the same slope, but different y-intercepts. So if we have an equation like y equals 2x plus 1, we can create a system with no solutions by making sure that our slope stays 2x and then giving a different y-intercept, like positive 3. Or if we start with y equals negative 3x plus 9, we can make another equation so that the system has no solutions by keeping the slope of negative 3 and changing the y-intercept again. This time we'll just make it negative 9 instead of positive 9. If we graph both of these, we can see why they have no solutions. So when we graph y equals 2x plus 1 and y equals 2x plus 3, we get two parallel lines. So they'll never cross, so there are no solutions. We could check the other one where y was negative 3x plus 9 and y was negative 3x minus 9. So again, we see two parallel lines that will never intersect. Now let's create two systems that have infinite solutions. Infinite solutions have the same slope, the same y-intercept, so this means that they're multiples of each other. So if we have an equation like y equals 2x plus 1, we can create another equation that would give us a system of infinite solutions if we multiply it by any number. So let's say we multiply the entire thing by 2, we'll get 2y equals 4x plus 2. So when we graph this system, they'll form the same line, meaning they have infinite solutions. Or if we have y equals negative 3x minus 4, and we want an equation with infinite solutions, we can even multiply by negative 1, giving us negative y equals 3x plus 4. As long as we multiply everything in the equation by the same number, we'll have a system of infinite solutions. To recap what we've learned, a system of equations can have exactly one pair of solutions, no solutions, or infinitely many solutions. If there is one solution, the equation will have different slopes and different y-intercepts. They will intersect at one point. If there are no solutions, the slope will be the same, but the y-intercepts are different. The graph will show two parallel lines. And finally, if there are infinite solutions, both of the slopes and y-intercepts will be the same. The graph will show two identical lines on top of each other.